So you've been asking how these incredible AI platforms actually get put through their paces.
Right, and also what all this buzz about the powerful chips really means.
Exactly. So today, using your questions as our guide, we're going to, well, dive straight in, give you the essentials on AI testing and the hardware behind it all.
Yeah, let's try and unpack what makes these systems tick, and importantly, how we know if they're actually working the way they're supposed to.
Okay, first up then, the types of tests. Listeners asked about that. It sounds like it's not just one standard test for everything, is it?
No, not at all.
And what about parallel testing? Is that a thing?
Oh, definitely. Think about it. Testing a self-driving car AI is vastly different from testing, say, a chatbot that writes poetry.
Right. Different jobs, different tests.
Precisely. So for a language model, we're looking at its grasp of context, maybe how coherent its answers are. For an image AI, it's more about accuracy. Can it spot the cat in the picture? That kind of thing. And yes, parallel testing is very common. You often test different abilities, maybe language understanding and translation at the same time.
So it's faster that way. Get a fuller picture more quickly.
Exactly. A simultaneous check on various skills.
Makes sense. Now, who's actually doing the testing? Is it the people who built the AI, the developers?
Well, initially, yes. A lot of the initial testing happens internally. The development teams, they know the system inside out.
But is that enough? What about bias or just seeing what you expect to see?
That's a really good point.
Yeah.
And that's why, especially for important applications, there's a growing push for independent evaluation.
So outside groups, specialized firms.
Yeah. Exactly. To get a more objective look. You also asked about independent verifiability. That's still a challenge, frankly.
Why is that?
Because many AI models are proprietary, black boxes sometimes. But the industry is trying, developing benchmarks, common frameworks, ways to allow more external review and comparison. It's a work in progress.
Interesting. Okay, that covers the testing side for now. Let's switch gears to the hardware, the chips.
Yes, the silicon.
You were asking about CPU chips specifically, but also just.
Yeah.
Why does AI training need so many chips? What's the real deal there?
Right. So this is where it gets, well, pretty fascinating. CPUs, central processing units, they're the traditional brains of computers, right? But training modern AI involves just a staggering amount of calculation. And CPUs aren't always the best tool for that specific job.
So not CPUs then? Or not just CPUs?
Mostly not just CPUs for the really heavy lifting of training.
Yeah.
We rely heavily on specialized hardware. You hear a lot about GPUs, graphics processing units.
GPUs, like for video games.
Exactly like for video games. And also other specialized chips called AI accelerators. When people say so many chips, they usually mean large clusters of these GPUs or accelerators working together.
Okay, so why GPUs? What makes them better for training AI than a standard CPU?
Think about how AI learns. It's like showing it millions, maybe billions of examples to spot patterns. This needs countless calculations, many happening at the exact same time.
Yeah.
GPUs were originally designed for graphics, right? Rendering all the pixels on a screen simultaneously. They're built for parallel processing, handling thousands of small tasks all at once.
I see. Unlike a CPU that does things more step by step.
Pretty much. A CPU is great for general tasks, one after the other, very quickly. But GPUs excel at doing massive numbers of simpler calculations in parallel. And that structure, it's incredibly efficient for the math involved in training deep learning models. Much, much faster for that job.
So these big clusters of GPUs, they're like the engines doing the actual teaching, the heavy computational work.
That's a great way to put it. They are the engines powering the learning process. And honestly, the huge leaps we're seeing in AI, they're tied very closely to the advancements in these specialized chips.
More powerful hardware means more complex AI we can train.
Precisely. Better hardware unlocks bigger, more capable models.
All right. So let's recap quickly. We learned AI testing isn't one size fits all. It's tailored, often involved parallel checks.
And a mix of internal testing with a growing role for independent evaluation, though verification is still evolving.
And the whole needing so many chips discussion, it really boils down to the need for massive parallel processing power during training.
Yeah, power provided most efficiently by specialized hardware like GPUs, not just traditional CPUs.
And connecting those two things, better testing and better hardware. They really seem like two sides of the same coin for AI progress, don't they?
Absolutely. You need both to advance responsibly and effectively.
Which actually brings up a final thought for everyone listening. As these AI systems get more sophisticated, thanks to better hardware, and the testing methods try to keep up, how do we actually ensure our evaluation abilities don't fall behind?
That's the critical question, isn't it? Keeping assessment in lockstep with capability.
Something definitely worth thinking about. Well, thanks for sending in those great questions. We really appreciate you joining us for this deep dive.
Yeah,